Welcome to Trim on the Basums and the When to Design Free, our next lecture here. Today, I would like to explain. About operators and expressions. I would like to explain about operators and expressions. Operators and expressions. Operators and expressions. But before these operators and expressions, I would like to explain briefly about these two things. These two things are different. An algorithm and a pseudocode, and zvinhu izvi zvinobvunzwa izvozvo. Maexaminers mazhinji anozvifarira obvunza algorithm nepseudocode madifference achoni, kana kunzi unogona kunzi explain pseudocode pane imwe certain question wozocoda code wazvaona. So today I want to explain about this. An algorithm and a pseudocode, they are different, but they are slightly different between them, because akada kufanana zvakada kufanana zvinhu izvi zvinonzi algorithm nechinhu chinonzi pseudocode zvakada kufanana, but that's why I told you before that there is a programmer and a real programmer. You see, those two people are different. So I assume that you will be a real programmer soon. So an algorithm is a step-by-step problem solving in a limited time. An algorithm is something which can be executed with respect to time. So in this case, algorithm chitori code chaunenge, but it's represented by a flowchart. It uses my charts which present John's algorithm. But you should know this is a step-by-step problem solving in a limited time. In a limited time, this is our keyword. In a limited time. So mwambona kuti patinorana program yedu ku code blocks pepe inotiudza kuti 8 seconds kana inotiudza 2 minutes 8 seconds, but the program inoexecutwa nemaseconds inogona kutiudza kuti 15 seconds ndodza execute code, and you're going to do like, let's give an example like this program. Let's run this program. You see 0.2 0.2222 seconds time execution time. This one is what we call limited time for this program. If we increase number of lines to the compiler, it will automatically increase the time. So in this case, we're saying oh, I didn't stop this. It doesn't matter. This case also, it is an algorithm rather run. So in an algorithm rinongopresentwa chete uchishandisa macharts like a flowchart. You should read about a flowchart because it's the main chart inoshandiswa to present algorithm. Then a pseudocode. A pseudocode is another technique of presenting an algorithm. We are just explaining the same thing, but the difference now is about how we are going to explain it. So in this case, a pseudocode or false codes are instructions that mimic the program code. That means that simulates the program code. It's not the actual code, but it simulates the program code. It mimics the program code. These are English-like statements. That explain the code to be executed. So pseudocode yakasiyana algorithm pakuti pseudocode explain or instruction some statements in English. So pseudocode can be read by someone from faculty of counseling and faculty of commerce, but an algorithm cannot be read by someone from faculty of business. That's the difference. Pseudocode, these are English-like statements. Then algorithm, this is like a code. a syntax, but in form of a chart. Simple. Let's go to operators and expressions. What is an operator? An operator are symbols that tells the compiler what to do, used to craft logic like addition, subtraction, multiplication, and division. So we are saying these operators are used to craft the logic, like they're used to craft the logic. Like we can declare our variables and say a, b, then we can craft our logic a plus b, then we execute the logic and we get the result. These are operators. Operands are variables and values that are used to perform the logic, you know. So the logic yatogadzira toisa maoperators pakati pechi pema values and variables like a, b, 2. These are operands, you know. So let's just go to the code and see what we are explaining here. So we want to declare the this code. Let's look at this code. Let's say what will happen. Int a is equal to 2, and then we'll come here assign int b is equal to form to terminate it. So we want to craft the logic. Tatisus, my operators, they are used to craft the logic, you see. So we are saying int sum, and in sum we want to add these two values, and in the sum is equal to a. What happened? What happened? So we want to craft the logic. Say int b is open for, then we terminate. Then we craft the logic here. Int sum is equal to a plus b. Then we terminate, and this is the logic. This is the logic. This is the logic. You know. So sum is equal to a plus b. This is our logic. This one is an operator, and this one is an operand. You know. So do this so that we can see. So that we can to get some. Yes. So in this case, we are saying int a is equal to 2, and b is equal to 4. So we do have our logic here. Therefore, we can say the sum is isn't it? Then we are printing sum, you know. So let's run inside. Let's stop this. The sum is 6. Beautiful. We're fine. So the logic, we use operators and operands to craft logic. You see? So we do have different types of operators. Do you have different types of operators? In this case, let's do this. do you have types of operators? Let me do this. So we have different types of operators. Also, we have arithmetic operators. We do have logical. We have logical operators. Then we have the last one. This is the relational operators. You know. So these operators are these arithmetic operators. It's like multiplication, addition, subtraction, division. These are in logical operators. We have this one, and then we have the for operator. Then we have the exclamation mark. So in this case, this one, everyone is familiar of these operators because they are mathematical operations, the arithmetic operations. Then logical operations. This is what we call AND operator. Then this one is called OR operator. Then this one is called a NOT operator. You know, this one is used to just to validate something. You want to say the password is not equal to something, we use this one. You know, so let's go to the relational operators. Relational operators, do we have equal? Do we have the less than? Do we have the greater than sign? At some time, or do we have less or equal to? Then we do have greater or equal to. Fine, beautiful. That's sort of what. I'm not sure where we are with the equal sign. I'm not sure about this. I'm not sure. But these are the relational operators. So these operators are used to validate code. They are used to validate code. Like let's see how they are used. They are used to validate code. This operator, they are used to validate code. Arithmetic operators and relational operators and stuff also. They used to validate. Let's see. And these operators, these arithmetic operators, they retain a value, but these operators, they retain a boolean. They retain booleans, true or false. Then true. Do this one. We are saying logical operators and the relational operators, they retain booleans, true or false. So true is equal to 1, then false is equal to 0. False is equal to 0. So let's see practically. We are saying int A is equal to 2, int B is equal to 4. So we want to say our logic, and want to declare our logic here. Yes, want to declare our logic. Want to print this an integer. So want to present it. Then we want to know if A and B are equal or they are not equal. and it will return a boolean. You see, not A or B to return a boolean because it's true or false, you know. So it's what we're saying, and I'll print A is equal to B. Let's see. Let's run this problem. Say return 0. Unexpected declaration or statements to end of input. Say 0. Listen. Return. Let's run this. Return a boolean. Return a boolean. So it's return a boolean. Let's use an if statement. You know, let's use an if statement to validate this. You know, this one. Support. I will demonstrate this in the next lecture. These operators, because this one I demonstrated it in this lecture. So in the next lecture, I will demonstrate how we can use these things.